It is difficult. How is it possible that electric fields do not interact with magnetic fields, electric fields do not interact with gravitational fields, and how is it possible that a gravitational field can deflect a beam of light? How is it possible that an electron, charged electric particle, what it is, has been deflected by passing a magnetic field if they don't interact with each other? And that is complicated, that is difficult, because at the same time two processes take place. One process is that only corresponding fields are interacting with corresponding fields, and this implies only electric fields interact with electric fields, and only magnetic fields interact with magnetic fields, and only gravitational fields interact with the gravitational fields. But we have to understand that two aspects are happening at the same time. For a beam of light, like a laser beam, there is interaction with a gravitational field, because every laser beam is surrounded by its own gravitational field, and the gravitational field around the laser beam is interacting with the gravitational field, for example, a black hole. And when an electric field is interacting with a magnetic field, like an electron passing magnetic field and being deflected by it, that is only because of the Lorentz transformations, because magnetic fields are being transformed into electric fields due to their relative velocity. And the second part of the process, which unifies everything in the whole universe, is the force. Because when two corresponding fields interact with each other, the result is a force. And the force is universal. So the forces total can always be added according to Newton's law: electric forces, magnetic forces, gravitational forces, inertia forces. All the forces together always have to equal zero in every direction, at every location, and at every time. Now follows a very important step by applying Ampere's law into this equation. The law of Ampere has been expressed in an integral form, which is the middle equation, and at the bottom the differential form of Ampere's law, which indicates the current density G expressed as the cross product the magnetic field intensity expressed in ampere per square meters. We apply now Ampere's law into the force density equation for the Coulomb force, and we find that the total expression for the force density expressed in Newton per cubic meters is the electromagnetic field intensity cross product the curl cross the field intensity for the magnetic field. And this equation looks different than what it represents, because it looks like this is the interaction between two magnetic fields, the field intensity H, but it is in fact Coulomb's law, the interaction between a charged particle moving relative to a magnetic field and being deflected. This is in fact that by the motion of the electric particle, the electric field around the particle has been transformed into a magnetic field. And it looks like the interaction between two magnetic fields, but it represents the interaction between an electric particle and a magnetic field. And this is a fundamental aspect of the Lorentz transformations, that electric fields appear like magnetic fields and magnetic fields appear like electric fields due to relative velocity. And this equation is in fact now what we need to find the total force for the total interaction between electric fields, magnetic fields and the inertia of fields. And we have to realize that we're talking about something we do not know what it is, because nobody in the whole scientific world knows what an electric field is. It is a property of space, that's all we can say about it. A magnetic field is a property of space, but that's all we can say about it. And a gravitational field is a property of space, that's all that we can say about it. But we have no idea, in fact, what this vacuum, what we call vacuum, is. Is it something like, according to Einstein's suggestion, that space is empty, it's just nothing? But how is it possible that something that doesn't exist, that is nothing, has all kinds of properties, has a permittivity, has a permeability, has fields, electric fields, magnetic fields, gravitational fields, and it is like we're speaking about a world we do not understand, and that's exactly what we do here in science. We speak about things we do not understand, but Newton had the power to at least observe the universe, learn from it, and express it into simple equations. And in fact, his second law of motion is not Newton's law of motion, it's nature's law of motion. Newton just observed it and wrote it down. And what is for us a powerful aspect is that from the world we do not understand, the world of fields, electric fields, magnetic fields, gravitational fields, by interaction these fields are transformed into forces, and forces is something from Newton's world, is something from nature, is something we all know. Everybody knows about the force. Everybody sometimes banged into something and felt the force. The force is something what we can feel, the force is something which is part of our reality. And because it is part of our reality, it interacts in all kinds of ways. And as soon as electric field interaction has been transformed into a force, and a magnetic field interaction has been transformed into a force, and a gravitational field interaction has been transformed into a force, then we can apply Newton's third law, that the sum of all these forces always has to be zero. And because magnetic fields are not located at one point, we have to replace the force by the force density expressed in Newton per cubic meter, and the force becomes something which is now a universal property in space, and the total force density for all the interactions there are, and it doesn't matter what their origin is, always has to equal zero in every direction, at every location, at every time.